In this example, we're going to use algorithms to multiply integers. So algorithm sounds like a fancy word, but it just means a process by which we could systematically find the product. So you're probably familiar with the algorithm for multiplying numbers already, but we're going to develop it a little bit so you can see why it works. So first we're going to start by a picture that's similar to the example we used before. And it says to label the rectangle below that represents 14 times 23 by place value. So notice I have it partitioned into these pieces, 4 pieces, and this is labeled 14 and this is labeled 23. So to partition by place value, what we mean, let's use a highlighter. This is 20, so that's our 20s place, or our 10s place, 20. Here we have 3, so this is our units place. So this equals 23. Just going to cross that out so we know which piece we have. Now let's do this for 14. The tens place for 14 is 10. So we have 1 10 here. And the units place for 14 is 4. So we've labeled this by place value. 20 is in the tens place and 3 is in the units place for 23. 10 is in the tens place and 4 is in the units place for 14. Let's move to the next part. Find the areas of each of the 4 smaller rectangles in which the big rectangle is partitioned and label them in the figure above. So here we have 4 rectangles, and if we added or summed these 4 pieces together, I think you'll agree that we would get the entire rectangle. So we can find each of these individual rectangles' areas, and we do this by multiplication. Well, this rectangle right here is 20 by 10, and 20 times 10 is 200. So the area in here is 200, and remember this makes sense before, when we partition them using base blocks, this was our 2 flats right here. Now let's move to this rectangle. This side length is 3 and this side length is 10. Well, 3 copies of 10 is 30. So this piece right here is 30. And remember when we made the base blocks, this was 3 rods, and 3 rods does equal 30. Now let's look at this rectangle. So up here we have 20 is this length and 4 is this length. Well, 20 times 4 is equal to 80. And remember with the base blocks we had 4 rods here going all the way across, of course, and we had another 4 rods here going all the way across. So that's a total of 8 rods, which is 80. And over here is where we had all of our units. This side is 3 and this side is 4, and remember we had 12 units. 3 times 4 is 12. So now we found each of the areas of the 4 smaller rectangles, 200, 30, 80, and 12. Let's move to the next slide. Now let's start by labeling this in our rectangle. So we have this was 200, this was 30, this was 80, and this was 12. So now let's read the next problem. Represent this multiplication using the extended algorithm. So the extended algorithm, we're going to call the extended algorithm using all of these pieces and summing them up individually to find our multiplication product. So let's set this up. We have 23 times 14. Now we're going to draw our line, and that means this is equal to. So you probably remember doing this in school when you were younger. Okay? So we're going to find all of these four products and relate them to this expression. So starting with 4 times 3, well, that was our piece right here, which is 12. Now we're going to do 4. 4 times 2 is 8. That's probably how you remember doing the standard algorithm, which we're going to do next. Remember, this means 4 times 20 because the 2 is in the tens place. Well, that's this piece right here. So 4 times 20 is 80. Let's start to highlight these to connect them. So there's 12, this piece right here. 80 comes from this piece right here, which is the 20 times 4. Let's look at the next piece. Well, here we would have 110 times 3. 10 times 3 is 30, so that will be our 30. So let's see, this applies to this part of the rectangle. And finally, 1 times 2 is 2, but this is 10 times 20 because they're both in the tens place, and that is 200. So here's our 200. So that's where this sum is coming from, or this addend is coming from. And I'm saying addends because now we're going to add these all up. Okay, so if we add up these 4 pieces, that will give us the sum. So we're out of room a little bit, so I'm going to move this up here. We have 2 ones, 2 units. Here we have 8 and 1 is 9, 10, 11, 12. 12 rods, so that's 2 rods, and we'll carry the 1 into this column. And then we have 3 flats, which is 322. So basically the extended algorithm, we did our 4 pieces of multiplication, we just didn't simplify them as much as we're going to do in the standard algorithm below. But this really shows you where all of the pieces are coming from. So now let's connect this to the standard algorithm. So we'll do 23 times 14. And the standard algorithm condenses some of these steps so you don't have such a big list of things to add up at the end. So we still start with 4 times 3. We start in the ones place, and we say that that's 12. So we put a 2, but then remember we carry a 1 over here. And this is something we're going to add on after we do the next product. So here we have 4 times 2 is 8, and then we add on the 1, which is 9. So we have 92. So notice where this is coming from. This is the combination of 12 and 80 combined together, but now we have them in one line, 92. We had the 12 ones, we carried the 1, there's our 1 that's carried, and then 4 times 20 was 80, plus our 1 is 92. Let's move to the next row. Now you probably remember at this point we put a placeholder of 0 here. And the reason is now we're multiplying by this one, but this one is in the tens place. So when you multiply something by 10, it's just like adding a 0 to the end of it. It's 10 times as large, so you put a 0 at the end. So next we would multiply 1 times 3. So this is 10 times 3, which is 30. So 1 times 3 is 3, and notice because we put this place value holder here, we do have a 3 in the tens place for 30. And next we have 1 times 2, which is 2. We write that to the left, and notice that's in the third spot from the right, so that means this 2 is in the hundreds place, and it was 10 times 20, which is 200. Now notice we have 230. Looking above, this is just combining the 200 and the 30 from this piece. Now we can add them together because we still want to find the sum. 2 plus 0 is 2. 9 plus 3 is 12. So we have 2, carry the 1, and 1 plus 2 is 3. So notice our results match up, 322 and 322. And this was our standard algorithm, and this was our extended algorithm.